Hello everyone, I'm back with you with another video lecture. This time it is on inheritance, another pillar of object oriented programming. So let's get going. So, inheritance, the moment the word comes into your mind, it gives an idea that something is actually coming to you, inherited. You know, we all know what we carry from our father, forefathers, and all the values, the genes, DNA, right? So, children inherit social values also, genes also, DNA definitely from their ancestors, right? And inheritance can be defined as a process by which one object acquires the properties of another object. Same way as we inherit different traits, values from our ancestors, right? Now, this is important. Why it is important? Because it supports the concepts of hierarchical classification. Classification, we know it is very important. So, if we have inheritance, it is easier to maintain that. Now, let us take or consider an example which we have already taken, that is of the animal family. Let's talk about jaguar, tiger, cat family. So jaguar actually is a part of cat family, and which in turn is a part of mammal, which finally is a part of a bigger class animal. So animal, mammals, and so on. Now, without the use of hierarchy, every object would be required to spell out its characteristics individually. That means everyone or every individual will have to have its own characteristics defined separately. Like in case of our dog family, we can easily say what are the similar traits. So when we use inheritance, an object is required to define only those properties which make it unique with the class or a part of the class, right? Like we have animal, mammal, cat family, dog family, and jaguar, suppose, is from the cat family, right? So we know the properties of jaguar, lion, tiger, they all come into cat family. Okay, so jaguar can inherit its general attributes from its parent cat family, and cat family from mammal, and mammal from animal. So the hierarchy is maintained, right? So to be more specific, we can say that a class of animals such as mammals would have more specific attributes like teeth, memory glands, right? Paws. This would be the subclass of superclass animal. We'll be talking about subclass and superclass in the lecture. By considering the class, we can know the behavior of that class. We know that if you go in front of a tiger, what tiger is going to do, that can actually be easily predicted. So inheritance interacts with encapsulation also, right? If a given class encapsulates some attributes, then any subclass will have the same attributes plus any that it adds. So it helps in encapsulation also. So inheritance is important in that case also. We'll be seeing things through examples, and we'll have more examples later in the lectures. But for now, let us just have a look at this and consider you walking in jungle, and if any of the cat family member comes in front of you, and unfortunately hungry also, or a man eater also, then only God can save you. Okay, we know that very well. So you cannot even run because they're faster than you, but only luck can save you. Okay, so inheritance is a mechanism that allows a class or a subclass, you can say, to inherit the properties and behavior of another class, a superclass. We'll be talking about subclass, superclass, base class, superclass are identical. We'll be talking about this after the this slide. We'll be talking about this also in the coming lecture. Okay, it enables code reuse by creating a hierarchy relationship between the classes. So now subclass can inherit attributes and methods from their superclass and add their own specific features or override inherited behavior. Overriding is possible. We'll see through it through an example. Now, inheritance promotes code organization, modularity, and extensibility. Okay, so using inheritance, you can do a lot of things like organization of the code, modularity of the code, and extensibility of the code. Okay, so we have to remember the key concepts we just came here. Base class, we have discussed about base class, superclass, and subclass also. So let's look at base class. It is also known as the parent class or the superclass. So either you can switch over the names. Actually, base class, superclass is same, but we have put it in different sections here, parts here. Three parts we are having: base class, subclass, and superclass. Sometimes we use superclass word, sometimes we use base class word. Why I put it separately? Because we have a keyword called super. So that's why I'm just putting it aside and making it like look little different, but they are same actually. I'll come to the example and you'll know that base class and superclass are the same thing. Okay, now a base class is a class from which other classes inherit properties and methods, right? And also it serves as a blueprint for creating subclasses, right? Now, the base class contains common attributes and behaviors shared by its superclass, right? So, first of all, class inherits properties and methods. Second, blueprint. It is a blueprint. It is a blueprint for creating subclasses, and it contains common attributes and behaviors shared by its subclasses. Okay, so let's come to now subclass. But before we go into that, let us look at an example. I'll just put an example here, a simple code here, and you will be able to understand. I'll just put it in the slide itself, and you will be able to understand what it is, what I'm talking about. Okay, so here is the code. We have a vehicle class, which is actually your base class. Okay, we call it super class, base class. I'll just put it as base class, and we'll be running the codes also, so let's see. So maximum speed initialized but not put any values. Then we have two methods, void, that is start and stop, and we're just displaying vehicle started or stopped. So this is a base class. Okay, so we have a base class here, just an example, but we'll be looking at the broader examples so to understand it better. Okay, we'll be having two more examples, but let us talk about a subclass first, and then we'll be going for the superclass and the final example where we will be assembling everything together. Okay, now a subclass is a class that inherits properties and methods from a base class. So it is inheriting. A subclass, a class which inherits. Okay, and where will it inherit from? Superclass. Okay, now it can extend and specialize the functionality of the base class. So whatever the functions are, it can extend that. A subclass can have additional attributes and methods beyond those inherited from the base class. So it can have more methods. You can add methods, not that it just what is there in the superclass has to be in the base class or the subclass. Okay, so subclass can have its own attributes, methods also, and since it is inheriting from the superclass, so it won't be requiring those methods to be or instances to be declared again here in the subclass. No variables required to be declared again, no methods to be declared again. Whatever in the superclass is there is inherited by the subclass. Okay, so we will again have a look at a very simple example where we can have a car class which can extend the vehicle class, and we'll be talking about this keyword which is going to come now, that is extends. We'll be talking about this, but let me first put the example. I hope the code is clear. Yeah. So class car extends vehicle. Vehicle class was the super class. You can see the base class. So class car extends vehicle, and we have number of doors here. Then we have door, that is we are just printing car door is opening. This is just for the sake of example, nothing practical about it. There's nothing practical we can do in this unless we put on some parameters, we pass on some, or we connect it with something concrete. And but for now, just for the sake of example, I'll be putting some more examples with the clearer vision so you can easily understand that, and we can have a look at it also. Okay, so let's talk about now superclass, or let's talk about extends first, and then we'll go ahead with superclass, because extends keyword is very important in inheritance. We have to understand it thoroughly, okay, before we go about superclass, because superclass and base class are the same thing. Okay, so first of all, extends inheritance helps in inheritance. The primary purpose of extends keyword, what is the primary purpose, is to extend, to enable inheritance, which allows the subclass to inherit all the non-primitive members. Okay, not the private members, fields and methods from the superclass. This includes both inherited and overridden methods. Overridden methods are methods which are written again with different parameters. We have seen that. Okay, then we have is a relationship. This is another very important part. The relationship between the subclass and superclass is often referred to as an is a relationship. It means that a subclass is a specialized version of the superclass. That means sharing common attributes and behaviors, but also adding its own unique features. Like we discussed earlier, it can have its own features, methods, attributes, but it is inheriting the methods, variables, features from the super or the base class also. So we have is a relationship here. Now Java, we are talking about Java. So Java supports only single inheritance, and extends also can have single inheritance only. So Java supports single inheritance, and that means only one class can be inherited, that is super from the superclass. Only one can be inherited. Now this avoids issues related to ambiguity that can arise in multiple inheritance. Like multiple inheritance we have in C++, where more than one class can be inherited just by putting comma. We can inherit more classes in a single class. That is, my subclass can inherit more classes. Okay, but in case of Java, we have only single inheritance. So extends only extends single class, that is only one superclass. No, now we can have hierarchical inheritance but not multiple inheritance. That is, A can be inherited by B, and B can be inherited by C, but C cannot inherit A and B together. Okay, it is one, it's almost the same thing, but it is not actually the same thing. It is almost a similar thing. Similarity is there but not the same. Okay, because functionality is different. Okay, So let's talk about now access modifiers also. So when we use extend, that is when we are inheriting the superclass, the subclass can access the members of the superclass, which is based on the access modifiers, whatever access modifiers we have given. According to that, the members can be inherited. The subclass can access public and protected members of the superclass, but private members are not directly accessible. That is what I said earlier. Also, you can inherit uh, the members of the superclass like public and protected, but not the private members. Now, we'll talk about constructors in super. Super keyword is what would come. That is why we are having a super here. So when we create object of the subclass, it automatically calls the constructor of the superclass using the super keyword. So we use it or not, it is already by default there, which ensures that the superclass initializes code initialization of the superclass is executed before the subclass own code, before the code of the subclass. So superclass is actually initialized first. The code is initialized first before the subclass. So subclass is inheriting superclass or the base class. So super keyword helps in enabling that you use it or not. The super is there. That is why we have superclass separately. I've just mentioned it and explain also. Now, method overriding, we have seen that if a method in a subclass is the same name. Now, that is interesting, and we'll see through it an example also. And method signature as a method in the superclass. If you have same methods in the subclass and superclass, it is set to override the superclass method because we are making object of the base class. Okay, but we have method ways to handle it. Now this allows the subclass to provide its own implementation of the method while preserving the method signature from the super class. Okay, so this will allow subclass to implement its method by preserving the method signature from the superclass. It is preserved, but method of the subclass is executed. So that is overridden. So subclass method overrides the method of the superclass. If the method name is same. If we have add there, then add of your subclass will run. But we have ways to handle it. Okay. Now comes your superclass, which is the parent class, base class, whatever you say. Now the term super class is used interchangeably with the base class. That means you can have either the base name, we can either call it base class or we can call it a super class. Okay. So as we said, the superclass and base class are often used interchangeably to refer to the class from which other classes inherit. And it provides a higher level of abstraction and is used as a general template for creating more specific subclasses. Okay, so superclass, subclass, base class, uh, then we have other classes. We can have multiple classes, or we can have nested classes. We'll be talking and looking at the examples later. Okay, let us look at the simple code which is of inheritance. We have a class sum, that is the base class, and then we have a method to add your two numbers. Then we have a class compute which extends sum, that is inherit the class sum. And then we have calc which is calculating. Then we'll have the main class which calls the base class, that is we are creating the object of the base class. This is what we always do. Okay, and then we are just printing the result of compute, which is calc method is called. Okay, so let us run this code in VS Code and see what happens. Let me show that to you now. Let me go to VS Code. Okay, so let's go to VS Code. All right, should come now. Okay, yes, here you are. Let's run it. This is your example which we have already done. We have add, we have calc, we have add here. So return x plus y, we are having the production here. So common method is not there. So we don't have any override issues here. We'll just run it. So we have a base class and we have a subclass which is extending the base class. So let's run it. So you can run it like this, or you can simply compile. The answer is 80. Since we are printing just the obj.calc, we are not printing anything from here. Okay. So what happens here, x plus y, this is passed on to this function, and then we can print it here. Actually, you can see this one, add. This add is calling 6 plus 10, that is 16. So we get 16 here into 5, and what we get is 80. 16 into 5 is 80. So that is the result. You get 80 here. Okay, got it? So what happens when we extend, we are calling this method directly without using any object, right? Add here and add here. You can see we're calling this method directly because it is inherited, extended. Okay, so the superclass is extended, inherited, so we don't have to use any object. We can directly call it. Okay, so now we call it, and since this is 10, 6 plus 10, that is 16. 16 into 5 is 80. That is what we get. Okay, this is a very simple example of inheritance. We have a base class and a subclass. Let's look at another example where we can have some more classes, and when we where we can override also. So we have our famous animal coming back to us. Animal class, we have name here. We are just passing the name here, and in animal constructor, and this will be stored in name of the base class. This is the base class. Okay, and then we have make sound. You can have some generic animal sound or something, whatever you want to have. You can print anything. This is just for the sake of example. Then we have dog, which extends animal, and in dog we have the breed and super name. Now when I use super name, the name is taken from here, this one, whichever we will be passing. Okay, we'll see how we are passing to it. Then we have the breed, and we are just printing this dot breed as breed. Will be printing make sound, so and so makes sound. We'll be running this code and see. Then we have another class which is a cat family. So we had a dog family also and a cat family also earlier. So it extends animal and not mammal. You can have mammal also. So just skipped mammal. Actually, we can have mammal. Then we have the color. We are talking about the color of cat. Then here we are printing, getting the name, super name. Call the base class constructor to initialize the name attribute. Okay. Then we have color. We are storing the color. Then we have make sound. You can see why we have put override, because we have make sound here also and make sound here also. This for just for the sake of comment. It won't make any difference as such here. So make sound is here also, make sound is here also, and make sound is here also. So 3 make sounds are there, but let's see how we run it. So we have to create the object of the base class, which is your dog, and we have the cat also. Okay, which extends animal. So this base class is actually extended by cat and dog. Okay, so this part, dog, we create an object of dog, and we are passing name as Google. Breed is golden retriever. You can put anything actually, but Google is name of my dog, so I have put Google there. And I have golden retriever also. So the name is there, Google and golden retriever. So system out without println, we are printing dog.name, dog.breed, and dog.make sound. So it is making the sound, and we are getting the sound here from dog object. So it will make sound. We'll run and see what happens here. We have now cat has whiskers, and the color is gray. Then we are printing the name, color, and the sound. Let me run it and see what happens when I run this. See what I get. Google golden retriever woof. See, woof, meow, woof. Where is woof? This is woof. Okay, and this case it is meow. So we don't have any sound here because we are not using any super keyword. We'll be seeing that how we can use it. We can use super with make sound, and then we can override that in this case also. So if there are three classes, we can have here we have four classes actually. So we have two subclasses and one base class. So one base class is extended by two different subclasses, and we have the main class which inherits actually which creates an object of the two base classes, which in fact inherits the main class, that is your super class or the base class or the parent class. You can call it anything. Fine. I hope this clears your doubts about inheritance and how we use it. So let's get back to our slides, and let's see what else we have. We are going to end it now. Inheritance we have already seen. Okay, so all right. 1 minute. Okay. All right. So now let's get to the last slide. That is the end of the lecture. Okay. So this is the end of inheritance, and I hope the things are very clear. Just imagine yourself whenever we are talking about object oriented programming, everything is around us. Inheritance, we have live examples, we are all examples of inheritance. Okay, how we implement that, we use extends to implement it. So we can easily do that. So you can go through the examples, you can try the examples. So in the next video lecture, we'll be talking about the last pillar of object oriented, that is abstraction. And we will be looking at some more keywords required to understand object oriented programming. Okay, till then, have a nice day. Enjoy learning, keep growing, keep practicing. Do more exercises to learn better. Have a nice day.